Hi, everyone. Thank you for joining our webinar today on leveraging new planted trees data to improve forest monitoring. My name is Isabella Briga. I'll be your moderator for today's webinar. I see about over 100 people have joined already, so we'll get started. So I'll provide some welcome introductory remarks before you hear from all of our great speakers today. First, want to let you all know that this webinar is hosted in English, but it's also available in Spanish. We have live Spanish interpretation. So if you would like to hear the webinar in Spanish, please locate the interpretation globe icon. It should be located on your Zoom navigation bar, and you can select the language that you would prefer to hear today's webinar in. So again, it's going to be hosted in English, but being made available in Spanish. So I'll give everyone a moment just to select their preferred language. And I'd also like to note that this webinar is indeed being recorded. So everyone who registered for the webinar will receive a copy of the recording in addition to the slide presentation. So everyone will receive that over email in the next couple of business days. Also, we will be taking live questions at the end of the webinar, but if you have any questions throughout the webinar, feel free to use this Q&A chat feature where you can enter your question. So thank you again for joining. Again, if you have any questions, use the Q&A, and please use the interpretation, which is accessible to you all if you'd like to hear this webinar in Spanish today. So thank you all again for joining. I'm now going to introduce our great lineup of speakers. So today we're joined by Jess Reichter. She's a GIS research analyst at World Resources Institute. We're also joined by Astrid Verhegen, who's with ARHS. She's a scientific consultant for the European Commission Joint Research Center. We're also joined by Suzanne Peyer, who's a research scientist with the University of Washington, as well as her colleague Sarah Richardson, who's a research consultant for the University of Washington. Also joined by Mel Rose, GIS research analyst for WRI. And again, I'm your moderator, Isabel Briga, community agent manager for WRI. I'll be moderating today's webinar. And with that, we'll give you a chance to hear from our great speakers now, kicking off with an overview of the planted trees data set, SDPT. I'll now hand it over to Jess to walk us through this data set.
Thanks so much, Isabella. And hello, everyone. So mapping planted trees helps us better understand how forests are changing over time and allows us to distinguish tree cover change between natural and planted environments. In the past, globally consistent spatial data on planted trees has been lacking, and the spatial database of planted trees aims to fill this data gap. Next slide. So what exactly is the Spatial Database of Planted Trees, or the SDPT? The SDPT is a global database of planted forest and tree crop boundaries that was created by Global Forest Watch, and it's aimed at spatially differentiating these planted tree types from natural and semi-natural forests. So we conducted extensive research and outreach to compile, synthesize, and harmonize national and regional data sources of the world's planted trees to create this database. Version 1.0 of the database was first launched back in 2019, but the SDPT was established as a living database and continues to evolve as new data becomes available. So a version 2.0 was recently released on the Global Forest Watch platform last year. And with that, we published a technical note documenting the update. Shortly after that, we made a minor version 2.1 update in collaboration with the European Commission's Joint Research Center. This was a smaller and targeted update to improve tree crop coverage in the database across 4 countries. This version 2.1 is not available on the Global Forest Watch platform, but we did publish a short change log to document these changes, which can also be found in the same place as the version 2.0 documentation. And we'll also include information on how to access the version 2.1 data. So I'll share more on how to access that documentation shortly, but first let's dive into how you can access the database on Global Forest Watch. Next slide. So the Planted Trees database can be accessed on the Global Forest Watch platform, which I've included a screenshot of here. On the GFW map, you can select the land cover tab on the left and toggle on the tree plantations layer, which is emphasized here in red. Once this layer is toggled on, the layer will be added to the map in the legend, and the data will be visualized in a rasterized format on the Global Forest Watch platform at 30-meter resolution. However, if you would like to use the original vector version of the data, this data will be available for download. You can see on the map, the layer will show the extent of the planted tree boundaries visualized as general classes of planted trees, such as wood fiber / timber, oil palm, fruit, etc. And in the legend, you can select the I information symbol to access the associated metadata, including a link to the technical note documentation, as well as a link to download the database under the Learn More button at the bottom of the page. Next slide. So we also include widgets on our dashboard page to help you analyze the planted tree data and generate summary statistics surrounding this data set. Once you navigate to the dashboard page, you can select the land cover tab, and under this tab, there are two widgets related to the planted trees data set specifically, which you'll see here on the right side of the slide. These widgets are available at the country level as well as at smaller administrative levels. You can find the total planted area with a breakdown of the planted tree type, as well as the largest relative area of plantation area within a given country or administrative level. Next slide, please. At this time, we only offer the entire vector database for download. So it is a file geodatabase with each country included as a feature class. The vector database download is 6 gigabytes zipped and about 25 gigabytes unzipped. If this is a limitation to your access of the data, please feel free to reach out to me directly. My contact information will be made available at the end of the webinar, and I can assist you with obtaining a smaller subset of the data. For future versions, we plan to offer single country downloads or at the very least regional downloads to improve accessibility of the database. We also now offer the database on Google Earth Engine as an image asset. I believe we'll drop the asset pathway in the chat for those that would like to note that pathway, but you can also reference the slides in the recording of this webinar as well to reference that. Next slide, please. So to illustrate what the geospatial data in the SDPT looks like on a more local viewpoint, here is an example from Guatemala. You can download and pull the data into a GIS. Here, I've pulled in the feature class for Guatemala into ArcGIS Pro. And when you click on a planted tree polygon, you are provided with attributes about the polygon, including the vernacular name provided by the source data, a scientific name if available, and information about the source data set, such as the imagery year that was used to delineate the data and the method of delineation, along with attributes regarding the carbon sequestration rates as well. So these are the many attributes that we harmonize together to be able to house many different data sources in one database. And this is the data structure that you can expect to see throughout the entire database. Next slide. So next, I'll highlight some overall improvements that we have made from version 1 to the latest version of the database. So version 1.0 represented a mode year of 2015. And because the database is made up of many different sources that may be from varying years, we take the mode year of these data sets and make this the nominal year that represents the database. So because we have newer data sets added in version 2.0, and 2.1. This version is nominally representative of 2020. We also expanded geographic coverage from 82 countries to now 158 countries, and expanded the number of countries where planted tree species information is available from 43 to 52 countries. And the number of unique scientific names has also grown from 53 all the way to 287. Next slide. Another notable improvement is that this database now reaches near global coverage. The SDPT covers 91% of the total planted forest area reported by the 2020 FAO Forest Resources Assessment, with the SDPT reporting 265 million hectares of planted forest and FAO reporting 293 million hectares. Although the data sets in the SDPT may not adhere to the definitions used by FAO, this historical record of planted forest statistics provided in the FAO FRA every 5 years serves as an important baseline for us to compare to the SDPT. And on the left, we have a graphic showing the increase in coverage from version 1 to version 2 of the database. So you can see that we notably have more coverage in the boreal regions in Canada and Russia, as well as throughout Africa and Asia as well. Next slide, please. So the database has grown to have a variety of different use cases across forest monitoring and mapping. I'll quickly highlight 3 of these use cases, but I'm glad to have our other speakers with us today so that they can share each of these in more detail. First, the database can provide valuable information to those enforcing policies aimed at combating the illegal timber trade. Planted tree species information can help enforcement actors, such as those in the US enforcing the Lacey Act, to expedite inspections of timber shipments. And Suzanne and Sarah will touch on this as well. The SDPT has also been used as an input in various forest typology mapping efforts to either identify or exclude planted tree extent on a global scale. It has been used in the development of the Science-Based Targets Network's Natural Lands Map to exclude planted trees from their natural forest extent. It has also been used in the JRC's Global Forest Maps, which Astrid will share more on as well. The carbon sequestration rates, which are applied spatially to the database based on source and species information, can be used to map and model carbon sequestration for planted forests and tree crops, or used in comparisons with sequestration rates by natural forests. And this is something that Mel will share more about today. So as you can see, there are a variety of different use cases of this database that have evolved since the database was first published. So I'll pass it back to Isabella, who will introduce our next speakers.
Great. Thanks so much, Jess. That was a really helpful overview of the planted trees data set. Dropped some links in the chat, and great to see the improvements with this latest version. So of course, if you have any recommendations for the data source, we've also dropped in a Google form where you can provide your feedback. So thanks again. Now we're going to hear a bit more about the data origins and collaborative improvements on this data, looking at the planted forest timber data set. So now I'll hand it off to Suzanne, who's going to kick us off.
Thanks to Isabella for the introduction, to Jessica for the invitation to speak today, and to you both for your efforts in preparing for the webinar today. It's an honor to participate. Next slide. So today, Sarah and I will share another collection of planted forest data, more narrowly focused to timber species and trade. Part of this collection is composed of a subset of the SDPT version 2.0, which Jessica just touched on. I will speak to the motivation behind this project, and Sarah will provide details about the data. Next slide. The publication of this collection was a result of a collaboration among 4 organizations, including the team at WRI, which is interested in these data for the Global Forest Watch program, and our collective team at the U.S. Department of Agriculture, Animal and Plant Health Inspection Service, the University of Washington, and the U.S. Forest Service International Programs. Together, our group is interested in these data for inclusion in a reference system called Arbor Harbor, which we use for analyzing trade data. Taxonomy and geographic distribution of tree species forms the foundation of this system. Next slide. So specifically, we use the Arbor Harbor reference data and thus the planted forest timber data to evaluate the validity of U.S. Lasiac Declaration data. Established in 1900, the U.S. Lasiac prohibits the importation of species illegally harvested in violation of laws in the source country. So when importers file these declarations, which you see on the left, they must include very important information enclosed within the red box, namely the scientific name of the species that's harvested and the country from which it was harvested. It's the job of the Animal and Plant Health Inspection Service, LACIAC program, to evaluate whether the importers are in compliance with the local laws. Next slide. For a couple of reasons, the LACIAC specialists are interested in planted forest timber data, importantly to the species level. First thing is that the species in question could be introduced to a region outside of its native range, which is not uncommon for planted trees. An example of such a species is Tectona grandis, or teak, which is native to South and Southeast Asia, but it's grown extensively elsewhere throughout the tropics. So although the distribution of teak outside of its native range looks pretty well documented based on this map from GBIF, not all species are equally so. So then a second reason is for interest in these data is that planted forest species can be loosely restricted in terms of harvesting. In other words, the same species that is illegal to harvest from a natural forest could be legally harvested if taken from a planted forest. The LACIAC specialists are aware of such differing restrictions by species and country. Next slide. So although the validation of LACIAC declaration data was the primary motivation behind collecting these planted forest timber data, our team at the University of Washington also uses the data for research purposes. First, we use the data to train and test species distribution models, which you can see in the upper right corner. And for this, we ask whether throughout the world, where is it possible or plausible for a species to grow? And second, we use the data in the lower right corner to train and test species classification models. And for this, we ask whether we can distinguish one planted forest species from another using remote sensing and machine learning tools. And our intent is that both of these efforts will eventually contribute as well to validating LACIAC declaration data. Lastly, in the lower left corner, we have made these data publicly available for others to use. Since the publication of our article in November of 2024, there's been an interest in the article, the data, and the code, making us feel that this project is valuable to the broader community, and we hope that we can continue adding to the data into the future. And with that, you can go to the next slide, where Sarah will share some of the details of the data.
Right. Thank you, Suzanne. As Suzanne mentioned, I am going to go into some of the specifics of our planted forest timber data and how it relates to the SDPT. So as you can see, this diagram, it is from our publication, and it shows that our data set consists of two types of data: spatial or polygon data, which is A in the diagram, and tabular or non-polygon data, which is B in the diagram. Our polygon data consists of a subset of the SDPT version 2.0. It is a subset because we are exclusively interested in timber and species-specific data. And as just mentioned, the SDPT includes other types of planted forests, such as tree crops, and some planted forests which do not have species information. Next slide, please. This map here shows the concentration of unique species by country in our dataset. The darkest green countries, and therefore those that have the highest number of unique species, include Colombia, Peru, Guatemala, Mexico, and the United States. This makes sense because our initial search was focused on North and South America. And this map also clearly shows the areas in which we could focus future data collection, including Africa and Southeast Asia. Next slide, please. Here we have a brief summary of our data. On the left, you can see in total we have almost 600 species, 40 of which are CITES listed species. This data spans 94 countries with 1,017 unique species country pairs. And on the right, we have some of the top species in our data set and their conservation listings, which include Cedrela odorata, or cedar, which is a CITES species, and also listed as vulnerable by IUCN. We also have Tabebuia rosea, which is CITES listed, Sweetenia macrophylla, or mahogany, which is a CITES species as well, and listed as endangered by IUCN. Pectona grandis, also endangered, and Rosiodendron donald-smithi, which is a CITES species. Next slide, please. And to wrap up, I have some next steps for our data. A clear next step, as just mentioned earlier, is updating the SDPT to version 3, and also to update our planted forest timber data to version 2. We can focus on the areas with gaps, such as Africa and Southeast Asia, shown in the map below. And we are also interested in doing further analyses to link our planted forest data to tree cover loss information and trade data. The data that we've collected so far has proven to be useful to the broader scientific community, which we can see by the number of accesses of our publication and data, as Suzanne highlighted. And we hope to acquire more funding so that we can continue this work. Next slide, please. Lastly, we want to thank you all for listening and provide our contact information as well as the link to our publication. And with that, I will pass it back to Isabella.
Great. Thanks so much, Sarah and Suzanne. Really interesting to hear more about how this data was used. Also dropped the publication in the chat of the global planted forest data for timber species. So excuse me, thanks again. It's really great to see like how this data is being applied in research. And now we're going to talk a bit more about another use case, which is the global mapping, how this is also used in that area. So I'll hand it off to Astrid, who's going to talk us a bit more about this use case and how the data has been used in their work. Astrid, the floor is yours.
Thanks, Isabella. Good morning, good afternoon, everybody. So as Isabella said, I'm a consultant for the Joint Research Center of the European Commission, the GRC, and the GRC role is to provide knowledge and independent scientific evidence to support EU policy. In this presentation, I will introduce the global forest map that the GRC developed to support the implementation of the EU deforestation regulation that I'll refer to as EUDR in the rest of the presentation. And I'll showcase how the WRI SDPT dataset inform those global forest maps. Together with me for the Q&A will be my colleague, René Kolditz. Next slide. So we launched a website, the European Observatory on Deforestation and Forest Degradation, to give access to transparent data on forest. Part of those data are global forest maps that I will detail today. So there are two maps. The flagship maps is the global forest cover map for year 2020, 2020 being the cutoff date for the EUDR regulation. We will also produce a preliminary map of global forest type map to support the part of the regulation on degradation, and I'll come back to it. So just a note that we always like to state is that those maps are one of many. They are not mandatory in the context of the regulation, non-exclusive. It's advised to use it in combination with other data sets, and they are legally non-binding. They don't guarantee any compliance with the regulation. Here you see a representation of the global forest cover map showing the presence and absence of forests worldwide. This is a map that has not been created processing satellite imagery, but it has been produced by combining existing products and data. We are already with the version 2, and a version 3 will come at the end of the year. It's always for the year 2020, but new version allow us to incorporate any new products that would become available at global scale. We produce this map and the two maps on the Google Earth Engine platforms. The final products are available for download and they have a 10-meter pixel size. Next slide, please. So here some main figure. We also compare with the FAO-FRA area of forest and relatively close for a global assessment. We also conducted an accuracy assessment of our map, giving us an overall accuracy of 91%, and for the forest class, 8% of omission error, meaning area that we map as non-forest, but that should be forest, and 18% commission error, so area that we map as forest, and that should be non-forest. Technical reports presenting both the methodology behind the map and the accuracy assessment are available. The link will be at the end of my presentation, and Isabella will share it also in the chat. Next slide. Here is you can see the global forest type map. So as I said, it's more a preliminary map, and we hope to come with a consolidated version at the end of the year. There, inside the forest extent that we mapped previously, we are distinguishing three categories of forest. Primary forest, so with no visible human activity, naturally regenerating forest, and then plantation forest. So those categories are relevant for the timber or the wood commodity and the part of the regulation that is related to the degradation. Next slide. So as I said, those maps and also the global forest type map, they don't rely on processing of satellite imagery directly, but they rely on datasets that are based on Earth observation. And with the use of Earth observation comes some challenges. Especially for mapping forests. So one of the first and main challenges is to distinguish tree from forest. So we usually with Earth observation map tree cover, as you can see here for this example in Borneo, that is covered by tree cover. But if you look more attentively, part of those trees are all palm, and so they present an agricultural land use that should be excluded for a forest map, as we are only interested for forest land use. Another challenge is to identify land that is under a forest land use, but that can be temporarily unstocked. So in a plantation, in a planted forest that is being logged, you could have for some years not presence of tree, and this is extremely difficult to map with Earth observation, but we need to include that in a forest map. Then more specifically, talking with forest type, we have the challenge of identifying primary forests with precision and distinguish any natural forest from planted forest or plantation. Next slide. So there where comes the SDPT. And so we use the version 2.1 that Jessica presented earlier, that has new data source across Ghana, Cote d'Ivoire, Brazil, and Cambodia. And we use this distinction of the SDPT between the planted forest type and the tree crops type. So we use planted forest type information both for a global forest cover map and a global forest type map, while we use the tree crops information more specifically in the global forest cover map. Next slide. So to highlight how we use the SDPT dataset in our maps, I will just deep dive a little bit more in the methodology behind our maps. Here you see the methodology for the global forest cover map. It has 3 steps, and we use the planted forest area information in the first step being mapping the maximum potential extent of forest cover. So this is crucial because if areas are not included in the first step, we cannot classify them as forest cover in the later steps. And there we use SDPT to identify plantation that are not picked in other data set or temporarily unstocked forest. Then in the step 2, we are applying, let's say, the forest definition, and we are excluding areas that are outside this forest definition by applying overlays, doing Boolean decision rules, and there the SDPT tree crops is giving us information about any tree cover that would have an agricultural land use. Next. So here some example in the step 1 where we use the SDPT to identify planted forest. So here you have an example in South Africa of a pine, eucalyptus, and acacia plantation that were not picked up in other global dataset, and that we could add to a forest mask thanks to the SDPT information. Next. And here another example for this step 1, how we use the SDPT dataset to include in the forest potential mask of forest, old plantation of pine in Portugal, and that allow us to include it in the forest mask, even if some of the area could be temporarily unstocked. Next. Now, regarding the step 2, where we exclude some area, so having information from SDPT and especially from refined version 2.1, we can exclude from our forest extent area that are tree crops. Here you have an example in Brazil of coffee crops. And so you see all the area in pink is actually the area, those are coffee crops, and those are area that we could remove in our version 2 compared to our version 1, thanks to the information present in SDPT telling us that those are coffee crops. Next one. And this is the same, but at a regional scale. So we are in West Africa, we see Ivory Coast and Ghana, where cocoa trees are very present, cocoa plantation, and we had issue in our version 1 with distinguishing this from forest. And the inclusion of a cocoa map for this region in the SDPT 2.1 allow us, together with other datasets, to improve drastically our map in this region and to successfully exclude cocoa plantation from the forest class. Next. Quickly, for the global forest type map, there how we use the SDPT dataset is to directly identify area of planted plantation. So if there is any information that there is a planted plantation inside of forest extent, then we are indicating this in the classes planted plantation. I'll show you 2 examples. Next. So here is an example in New Zealand where you see in the very high resolution image that you have very similar forest, but there is one part of the forest is a natural forest and one part is a pine plantation. And having the information in the SDPT about this pine plantation, we can directly identify this in our forest type map as the category planted plantation and not leave it in a naturally regenerating forest or primary forest. Next one. Here, similar example where the SDPT informs us that there is this pine plantation in France, in the Landes area, and that is identified in a forest type map directly as a planted plantation class. Next one. So to conclude, as I explained, the GRC Global Forest Map rely on a wide variety of existing datasets. Concerning SDPT, more specifically, it allows us for the forest cover map to better map forest extent, taking into account some forest plantation that are not available in some dataset, unstocked forest, and then to exclude agricultural tree crops. And we saw the example for coffee and cocoa. Then for the forest type map, SDPT is really instrumental for distinguishing between natural forest and planted plantation forests. We still have several challenges with our map. One of them is how to distinguish tree crops like coffee or cocoa that are cultivated in agroforestry systems. And a new version of the SDPT will probably better inform on that. And for this reason, and we are really happy with the collaboration continuing with the SDPT team for next version of the global maps. Next. So with this, I would like to thank you for your attention. And here and in the chat, you can find links to the website to the Forest Observatory and to the report that we recently published on the methodology behind our maps and the accuracy assessment of the global forest cover map. With this, I'll give the floor back to Isabella, and I thank you for your attention.
Great. Thank you so much, Astrid. Really great to hear how the JRC Global Maps uses this data and how this collaboration is built on all this exciting work that you discussed. So thanks again. We'll now wrap up with our final use case, talk a bit more about how the data can be used in carbon flux modeling. So I'll hand the floor to Mel, who will talk us a bit through how this data can be used in combination with the carbon data sets on Global Forest Watch. Mel, the floor is yours.
Thanks, Isabella. So like Isabella mentioned, my name is Melissa Rose. I'm a geospatial research analyst at WRI in the Global Forest Watch and Land and Carbon Lab. My work specifically focuses on developing geospatial monitoring frameworks for mapping greenhouse gas fluxes in the land sector. And today I'll specifically be talking about our forest flux model. Next. So we use the spatial database of planted trees in our model to distinguish between planted trees and natural or semi-natural forests. And trees play this dual role in the global carbon cycle. Standing and growing forests store carbon and remove or sequester carbon from the atmosphere, while cleared and degraded trees store little to no carbon and emit carbon dioxide into the atmosphere. However, not all trees and forests are the same in terms of their sequestration potential or how much carbon they can remove or sequester from the atmosphere. So generally speaking, tree crops sequester less carbon than natural forests, and planted forests can sequester more carbon initially, but have lower overall carbon storage potential in the long term if harvested frequently. So whether or not a given area is a net sink or a net source of carbon depends on this balance between emissions and removals, which varies across both space and time. So to better understand the role of trees in the global carbon cycle and the balance between emissions and removals, Global Forest Watch creates globally consistent 30-meter maps of greenhouse gas fluxes using the IPCC National Greenhouse Gas Inventory framework applied to geospatial data. Next. So in its simplest form, how we calculate emissions and removals in our model framework boils down to these IPCC equations, which take activity data and multiply it by some emission or removal factor to calculate the gross emissions or removals. So removal factor is another term for sequestration rate, or the rate at which trees absorb carbon from the atmosphere. Next. We start out with maps of carbon stocks in the year 2000 and calculate how much carbon is stored in each carbon pool. So these pools include things like above ground carbon, below ground carbon, deadwood, litter, and soil. Next. And then to calculate how much additional carbon is stored in standing trees or new trees over time, we take maps of tree cover extent and tree cover gain and multiply those areas by a removal factor or sequestration rate. We use different removal factors for many different types of forests according to things like ecozone, climate, forest age, whether or not it's primary forest, secondary forest, mangrove, or planted trees. And in the case of planted trees, these values come from the spatial database of planted trees. Next. So similarly, to calculate gross emissions, we take maps of tree cover loss and multiply those areas by different emission factors according to how much carbon is stored at that point in time and some other contextual information like forest type, the driver of tree cover loss, and whether or not that loss was due to fire. Next. So then finally, using this IPCC gain loss approach, we combine our 30-meter resolution gross emissions and gross removals maps and we subtract our removals from our emissions from our removals, excuse me, to calculate the total net flux by forests from 2001 through 2024, which tells us whether or not an area was a net sink or a net source during that time period. Next. So to do this, we use separate sequestration rates for the types of trees that are represented in the spatial database of planted trees. So every polygon in the spatial database of planted trees has a specific sequestration rate according to its type. So to do this, we conducted a literature review to source removal factors for the best geographic specificity and or taxonomic specificity. So for polygons with species or genus information, in some cases, countries reported sequestration rate or a proxy for sequestration rate in their FAO planted forest assessments. And in other cases, we were able to source rates for that unique country species combination directly from literature like those listed here. Next. And then in other cases where we couldn't find literature or FAO reports, we used default rates reported in IPCC National Greenhouse Gas Inventory Guidelines, like those shown here for planted forests. Next. So if you're interested specifically in the removal factors for individual polygons, you can find this information in the attribute table that Jess referred to earlier. Next. We provide the above ground sequestration rate. Next. As well as the combined above ground and below ground sequestration rate in units of tons of carbon per hectare per year. Next. And we also know the source of the sequestration rate and its standard deviation. The sequestration rate, however, as I mentioned earlier, is only a piece of the puzzle when we think about the entire fluxes over the entire time period. So if you're interested in the overall removals, emissions, or net flux by planted forests since 2001, next. You can download the SDPT database from the map layer, which Jess referred to earlier, by clicking the Learn More button. Next. And next. And one more next. Sorry, Isabella. And then you can also download our flux rasters and 10 by 10 degree tiles from GFW's open data portal to explore flux trends within your SDPT polygon of interest. So if you're interested in just visualizing the data, the flux data, be sure to download the per hectare rasters. But if you're interested in calculating any types of zonal statistics, be sure to download the per pixel rasters instead. The open data portal has more information on those two different use cases. You can access that information by clicking the View Full Details button. Next. And with that, I guess I'll pass it off to Isabella.
Great, thanks, Mel. Really great to hear more about GFW's Forest Carbon Flux Monitoring Framework, and I dropped the link to the blog as well as the emissions removal and net flux data that Melissa mentioned in the chat, so feel free to take a look. I see we've already got a handful of questions, but please, if you have any questions at this point, use the Q&A and type your question. We'll prioritize the questions we've already started to receive live. So thanks again for our great speakers. I'll give you all a chance to turn on your camera. We're going to answer all the great questions that came through. We may wrap up a bit early if we get through most of these questions, and noting we're also joined by Renee Kolditz from JRC for the Q&A as well. So thanks again for all the great questions. I'm going to stop screen sharing so you can see all the speakers. But I'll go through the questions we've received so far in the chat. So if you have any questions, please feel free to ask in the Q&A. First, we have a question around, is the improvement in the China dataset spatial resolution plan for the next version? So Jess, would you like to take this question live?
Yeah, definitely. Thanks, Isabella. So yeah, very good question. For version 2, we did include an update to data on planted forests in China. This was sourced from Abbasi et al., who published a paper on planted forests in East Asia. And this included some dominant species that were mapped for planted forests, including in China. And so this data set is representative of 2016 through 2020. So it's a fairly recent data set and was a significant improvement from the coverage that we had in version 1. However, if you do have suggestions for new data sets in China that you're aware of, we'd love to hear them and encourage you to fill out the form that we've linked to be able to collect more information on any available new data sets. Thanks.
Great. And just another question that I see was for you, Jess. So also a question around, do you have trouble distinguishing broadleaf plantations? In particular, this person's asking from in Ecuador, these plantations are often confused with natural forests. So Jess, I don't know if you also have insights related to this.
Yeah, sure. So I think for Ecuador specifically, we do have quite good coverage. We are able to source information from the Ministry of Agriculture and Livestock, as well as the Ministry of Environment as well. So between those two ministries, we have a fairly good representation, I think, but there's always certainly going to be difficulties between mapping, broadleaf plantations or tree crops compared to natural forests. And so, I think being able to source data directly from the ministries themselves is a huge advantage to what we can offer with the SDPT and have data that, is coming directly from, a governmental source and can help us distinguish between those two forest types.
Thanks so much, Jess. Very helpful. I'll switch things up a bit and hand this question over to Astrid. This participant asked, what is the temporal coverage planned for the upcoming JRC Global Forest Watch map release? Astrid, would you like to take this question?
Sure, thank you for the question. So in terms of temporal coverage, we always cover the year 2020 because as I explained, it's for the implementation of the EUDR regulation that has a cutoff date in end of 2020. So our interest is always to map forest cover and forest type in 2020. But we improve when there are new datasets becoming available, and there will be new version, but I don't have a strict deadline that I can share with you, but there will be new version for the forest cover map and the forest type map. I hope this answers the question.
Yes, thank you so much, Astrid. Very helpful. And this question, I think, better suited for Jess. Does the WRI tree gain data already filter out these trees, or would that gain coincide with many of these areas? So, Jess, I think it'd be great if you could share a bit more about this and how folks can find this information on the GFW dashboard.
Yeah, great question. So the tree cover gain data that we offer on Global Forest Watch the coverage would overlap with the SDPT. And so one thing that we do offer on our dashboard page is if you go under the Forest Change tab, we do offer a widget at the country level where you can see a split essentially between tree cover gain that has happened inside of and outside of the plantations that are mapped in the SDPT. So this can be a really helpful resource to better understand, where that overlap occurs and where it doesn't.
Great, that's really helpful. And yeah, we shared more information also. If you all have any questions after the webinar and you've tried to access it, you can always reach out to us at the gfw@wri.org email. I will hand over this question to Mel. This question is around, how did you make the estimates for soil carbon fluxes? Would you like to answer this one, Mel?
Yeah, so we start out with maps of soil carbon stocks in the year 2000, like I mentioned. And then we use IPCC equations and default rates for soil carbon stock fluxes over the time period. So when there's a land use change, for example, there's a loss in soil organic carbon content, and that there's a time dependency over 20 years. It's a little complicated. There's more information that we can share with you in our original publication and a recently updated publication as well if you want to learn more about the specific methods that goes into all of it. But we use tier one equations and default assumptions, starting with a 30-meter resolution map of soil organic carbon stock in the year 2000. And this just measures soil organic carbon stock within the first 30 centimeters. So we only look at carbon stock there and the soil profile. And another thing to mention in regards to soil organic carbon fluxes. So previously we just estimated carbon or CO2 fluxes from soil. And this year we added a update to our model where we also calculate soil nitrogen mineral or N2O emissions from soil nitrogen mineralization according to IPCC guidelines for calculating that as well. So if you have any more specific information about like those equations, any of the input data sets, or the CO2 emissions versus N2O emissions side of soil carbon fluxes, I'm happy to go into details with you more as well. But I'll drop some of those resources in the chat so that you can look up the methods in more detail. And I'm happy to take any other follow-up questions if I didn't answer anything specifically as you would like to, any questions that you would like to follow up about.
Thanks so much, Mel. See, a few more questions are coming in. This one's more of a part two. So first of all, this participant says awesome work. And the first part of the question is around how relatively small number of species. So is this because of the nature of planted commercial sites? I'll share the first part of this question for Jess to answer first before I point to the second part. So Jess, would you like to speak to this first part of the question from Digimo?
Yeah, thank you. So yeah, I think, we certainly aim to collect as much species information on planted trees as possible, and include it when available. It is something that is, quite difficult to distinguish using remotely sensed imagery oftentimes. For tree crops, like, oil palm and coconut palm, they do have very distinct canopies that you can note from satellite imagery. However, other planted forest types, it can often be difficult to discern species information from those. So I think by incorporating data at the national level and from governments, it's often helpful for us to include that data because they can often have species information from forest inventories or other more direct mapping efforts that they've conducted to incorporate this information. And so, yeah, it's certainly difficult, and we hope to include more species information in future versions of the database.
Thanks, Jess. For the second part of the question, just wanted to note they would love to collaborate on cross-referencing the planted polygons with the species-specific occurrence data, especially for primary and regenerating forests. They're working on the latter at Treecopedia. So not sure if Suzanne, Sarah, you might want to jump in just to respond to that. And again, we will share the slides so the participant will have your contact information, but wanted to see if you want to speak to that as well, about that collaboration.
Yeah, Sarah, feel free to jump in, or Jess, anybody as well. So I feel your pain. I was looking at the Treecopedia, and obviously I didn't have a lot of time to go through the details of it, but just at my glance, I understand the difficulties that you're facing. So it'd be great to learn more about what you're doing, and I would love to follow up after this with a conversation.
Great. Thanks, Suzanne. I see another question that I'll hand to Astrid to maybe speak more about the forest definition. So the question is, does this data include data on natural trees that have been converted into forest cover? This is because in Africa, for example, they're explained that natural forests are more than just planted ones. So, Astrid, I'm not sure if you want to speak a bit more on how, from the perspective of how natural trees meets the definition of forest in particular, if you'd like to speak to this from your perspective.
Yes, I can try to answer that question. So for building our maps, we are relying on the definition of the UDR regulation, which is very close to the FAO forest definition that indicates forest with some criteria on tree height, 5 meter, on a minimum area of 0.5 hectare, and then on the land use, and the land use should be forest, not agricultural land use or urban land use. So any tree or group, area of tree that are fitting this definition are identified as a forest in our global forest cover map. And then the second map that I presented is going more in detail in this forest extent and try to distinguish between natural forest. And natural forest can be either a primary forest or a naturally regenerating forest. And so distinguishing those two categories of natural forest from planted plantation forest. So we are all of this is included in our forest cover map extent. I don't know if this is maybe, I hope this clarifies.
Great.
And I invite anyway, as I said, and the links were shared to go to the reports and to contact us in case of additional questions.
Thanks so much, Astrid. That's helpful. And yeah, again, I would encourage those who put questions in the chat, feel free to follow up over email with more context. We still have some time to go through the remaining questions here. I'll start with at the top from Jacob. Will SDPT be available as a feature collection vector on GE as well? Currently, the asset path listed seems to be for an image raster. Jess, would you like to take this question?
Yeah, it's a good question. So yeah, currently we only offer the database as a raster image on Google Earth Engine. We have tried to add the database as a feature collection. It is quite tricky because of the complex geometry boundaries associated with a lot of the polygons. It's a very large data set in size as well, which adds some complexities to getting it added to Earth Engine as a feature collection. However, I think if we do hear from folks that this is something that they are highly interested in and would greatly benefit from, we can certainly explore other ways to potentially get this data on Earth Engine as a feature collection.
Great. Thanks so much, Jess, for that explanation. The next question from Marina. What is the temporal coverage plan for the upcoming GRC Global Forest Map release? So, Astrid, would you like to come in and speak to this question a bit more?
Yeah, Isabella, I think we already answered.
Oh, yeah, that's correct. Sorry about that. I'll remove that one. We also have a question around, do you have an idea of how long after planting the trees are visible from remote sensing sources? So, Jess, would you like to, again, speak and provide more information for this question?
Yeah, so it certainly does take a few years to show up in the imagery. And so I think that is one thing that we certainly try to note in our technical note documentation that, a lot of these sources are going to be showing, mature planted forests. Some data sets do try to address including coverage of younger planted forests and tree crops, but, it certainly might take a few years for this to show up in the imagery.
Great. Thanks, Jess, for that. And then we also had a question around EUDR. First of all, thanks to all the presenters. Is it possible for JRC to combine those different approaches for due diligence in EUDR context for timber from Congo Basin? If yes, is there a database open source? Asher, would you like to speak to this question?
Yes, sure. So again, I like to refer to our reports detailing the methodology and how you can access the data. So the two maps I present today are fully available and downloadable. They are downloadable, they are available as an asset in Google Earth Engine. And so while one is informing on forest cover extent, and it's mainly thought for risk assessment related to the deforestation. The second one is more thought for the question is on timber, for timber assessment of the community of timber and the degradation, where we need to look at risk of degradation and deforestation. So, but we provide only one of many maps, and we strongly encourage any operator or a national ministry or authorities that want to work with the data to combine it with other data set. There are around existing some convergence of evidence tools, for example, developed by FAO. It's called WISP, and it allows you to combine for a certain plot of land information from different geospatial data set that can help you to conduct a risk assessment for the UDR.
Great, thanks, Astrid. I think another interesting follow-up question I think would be good for you, Astrid, or anyone else from the panel. They're interested in hearing more about how to distinguish coffee and cacao agroforestry plots, especially given that those types of plots can often be decades old and can appear like natural forests. So I don't know if Astrid, you'd like to speak to this, or if anyone else from the audience, I mean, excuse me, from the panel has any insights on this.
I can start, and I don't know if Jessica maybe has something to add. So we know that cocoa and coffee are really challenging. They are challenging if they are cultivated as, let's say, full sun. So only you see the tree of cocoa and coffee, but that is partially already addressed with some regional or global data set. They are coming, but it's still it's a challenge. And I show the difference between our two versions, or in like incorporating the new version of SDPT, we could improve mapping of those. But then another challenge comes when the coffee and the cocoa are cultivated under the canopy, because there with satellite imagery, it's really quasi impossible to see it. And for those, we are a little bit reaching the technical capability that we have with satellite imagery. Research is ongoing, and there may be data from the field. I mean, from like polygons, maybe delineating the different plantation could help to know where those crops are located. But it's definitely a challenge.
Definitely understood. Can be, yeah, definitely hard to distinguish between these types. I don't know if Jess, you have anything else you wanted to add?
Yeah, I think I would just echo what Astrid had mentioned, that, mixed species plantations and agroforestry systems such as those, can be quite difficult to pick up in satellite imagery, especially, at a moderate resolution of, 10 to 30 meters. And so I think being able to explore more sources that specifically map these forest types and include species information will be really important moving forward, and sourcing these maybe from national governments or other sources, that are completing forest inventories, like Astrid mentioned, having, more data from the ground to help validate that, and have manual boundary delineations will be helpful for that forest type specifically.
Jess. I see a few questions related to carbon sequestration. So Mel will try and combine some of these, but maybe this one from Wim just to start with. Is there a minimum plot size for reliable carbon sequestration estimation for above ground biomass. Would you want to speak to that live,
Yeah, it's
Jess?
a good,
I mean, Mel, sorry.
yeah, that's a good question. Um, Currently, no. So some of the IPCC data, the growth rates that IPCC provides are based on plot sizes or a number of studies that are pretty low, and so that's understandable. Um, the the key here is trying to come up with the best available information for as many species as possible globally, everywhere in the world. So we do have a number of like the sources that we use from different literature that do have more robust studies with lots of different plot sizes. We're working with a collaborator as well who's put together a global database of different plot data so that we can synthesize that information over larger areas. But currently, there are some of the default rates that IPCC uses that have some lower sample size. So we don't have a threshold necessarily there.
That's helpful. And yeah, I see a few more questions are I hope that answers some other questions about the carbon sequestration data, but I think we'll pivot and maybe talk a bit more about the importance of species level data as well. So I want to open up to Suzanne and Sarah to speak to that. And I think how it relates to this question from Federico around how can we track restoration combined with native timber species to silviculture? So not sure if you'd like to speak to that question. Suzanne or Sarah, or also kind of emphasize the role of species data in relation to this question. So would you like to address that, Suzanne?
I can start and feel free to jump in, Sarah. But I guess so. Our work is well, our work is really focused on being very rigorous with the species information and the geographic information and cross-validating, making sure everything is as well vetted, all the information is as well vetted as possible. And a big stumbling block has been just taxonomy itself. People like to, often people defer to using vernacular names, which can be really problematic. And since there are a lot of species that go with that vernacular name and vice versa. And so we've tried to be really rigorous with just having the correct, most accepted scientific name, because that scientific name is what connects data, different types of data. It's a common node between different data sets. So it's been a really important endeavor for us. So makes it usable to a broader community as well. And I guess the same is true for geographic locations too. And Sarah, I don't know if you'd like to speak to that. That's been an important part for us as well. How geographic names can also be as variable sometimes as the scientific names themselves. And so having a very standardized way of using the data is really important to us. I don't know if that helps to answer the question a little bit.
Definitely. Did you have anything else you wanted to add to that, Sarah?
I think Suzanne covered it pretty well. I just noticed a question in the chat that I wanted to add on to based on what Suzanne just mentioned about the species information. About the question says, do you collect ground truthing information through citizen science forms? And I think one thing that we used when we were going through our species names and making sure that they were up to date was I believe it is the GBIF citizen science observations. You can correct me if I'm wrong, Suzanne, but just wanted to mention that we did use that in our validation of the scientific names.
That's really helpful. And yeah, that was another great question. I did want to open up to all the other speakers too to speak to this question from Rachel about ground truthing information through citizen science forums. We definitely at Global Forest Watch promote citizen science. We didn't talk about this data set too much, but when it comes to, in general, collecting and ground truthing information, we work with varieties of partners on the ground through applications using the data from Global Forest Watch on tools like Forest Watcher, which is a mobile application that anyone can use offline in the field to collect this information. So we definitely rely on those on the ground who are using data sets from GFW and also verifying how this fits in and compares to local data as well as national data sets. So in general, with GFW, we definitely promote this spirit of citizen science and ground truthing. But I wasn't sure if Jess, Mel, you want to speak to that from GFW side? Anything else you'd like to add?
Yeah, I can also just quickly add, I think, kind of jumping off of what Suzanne and Sarah have shared on their timber species database or data set. I think that has been just a really useful reference for us and something that we want to incorporate more into the spatial database of planted trees in future versions because they collect information on a non-polygon level as well. So both, it could be more broadly at the country level or more localized information like point information. We're hoping to hopefully utilize that in the longer term by creating potentially a attribute called like a likely species attribute where, we don't necessarily have confirmation from a polygon, vector data source or raster data source that there is species coverage there, but we can pull in the timber species information that Suzanne and Sarah have pulled together from these non-polygon sources to help supplement and provide users of GFW with as much species information as possible.
That sounds great. And Astrid, I wasn't sure if there's anything else you want to speak to related to this question or go to the next one.
No, it's fine. Thank you.
Okay, great. I also saw a question around, well, this might be good for Mel. Is there already a practical and accessible organic carbon accounting through Earth observation, or is there always empiric measurements by soil sampling needed? So, Mel, I'm not sure if you'd like to speak to this question.
I'm not sure I understand the question. Can you repeat it?
Sure. Is there already a practical and accessible organic carbon accounting through Earth observation? Or I think this means are there always empirical measurements by soil sampling needed?
Yeah, I think that's a really good question. It actually brings up something that I didn't mention earlier when we were talking about the soil flux equation or our process for calculating that. And so that's a great question. And I think the general answer there is that Earth observations can always be improved based on ground sampling and connecting those two things. We're actually working with folks, Tom Hengel, who's producing Open GeoHub data set to improve the spatial resolution of the input soil organic carbon layer that we currently use. It'll have improved spatial resolution and much improved based on many more observations as well, connecting Earth observations back to ground truth data. And so I think that just brings up, in general, yeah, this need for both of those things, Earth observations and ground truth data to connect. So I wanted to highlight Tom Hengel and his group who are working on the Open GeoHub soils map, which will be a big improvement on mapping soil carbon and soil carbon fluxes moving forward.
Great. Thanks, Mel. That's helpful. And maybe related, if you'd like to take this one or open up to other speakers, from Jenna. She says, thank you to all the speakers. Does the data include blue carbon regions like those in mangrove restoration projects? If it takes a few years to show planted trees, how do you hope to improve the data over time to include younger planted trees or a higher resolution for remote sensing? I don't know if Mel or Jess, if you'd like to take this question.
Yeah, I can take the blue carbon question part because that's the carbon side of things. We do include mangroves, and so we work with Global Mangrove Watch to make sure that we're really delineating those mangrove regions and treating those separately than other forests. Because again, you have this issue when you're looking at it from the Earth observation perspective of how do you delineate those regions, especially in coastal regions. And so we use Global Mangrove Watch data to delineate mangroves and treat the use cases and how we calculate emissions or carbon for those areas separately. Yeah, and that's at least the application in the carbon model side of things. I'm not sure if anyone else would like to speak to that.
I can add on with kind of the second half of that question, targeting the younger plantations. And like I had mentioned earlier, this is certainly it's a difficult thing to map using remotely sensed imagery, and something that we want to improve upon in future versions of the database. So one way that we try to address this is by in our literature search for new data sets in upcoming versions, we do try to search for data sets that are addressing, capturing these younger plantations, both young and mature plantations or tree crops. And so, yeah, that's something that we hope to improve upon in future versions.
Great, thanks, Jess and Mel. We can wrap. I think we may be able to get through the remaining questions. We have a handful, so maybe we can just run through these, then we can end the webinar a little early, and we have concluding remarks from Jess. I'll just go through them in order, but this is from a researcher from India, Porchelvan. If new trees are like orchid, I think, yeah, orchards are planted, at what stage, for example, 2-meter or 5-meter height, will it be considered planted trees? And are there fuel wood plantations, the time span of around 5 years, which are gaining spatial in South Indian regions? Will those be included in the data sets? I don't know if Jess, generally you can kind of speak to the question around at what stage they're considered planted trees, and at what stage do wood plantations, are gaining this spatial resolution?
Yeah, so can definitely answer that. So I think with tree height, we certainly try to aim for 5-meter height as kind of being the aim for including planted tree information. I think the main thing that we do try to focus on is that the source data set is defining the data as being a plantation, a planted forest, a plantation forest, or a tree crop, using that sort of terminology. So orchards could be included in that. Definitions of these forest types, are going to vary from data set to data set, but we include the information on how that forest type is defined and references to the source information in our technical note. So definitely recommend referencing that for specific data sets that you're interested in. And it sounds like, there's some specific interest for India. I think India is a country where our data is a bit outdated. So if you do have suggestions for new resources that we can include in future versions of the data set, would definitely recommend reaching out to us through that form, because that's something that we would like to improve on since our data is a bit outdated.
That's great. And just I'll add a follow-up question, just in general, if you could speak to, because I think that's important in this use case in India, but it would apply to others in the audience, kind of more about the role of local versus global data sets and how that works with this SDPT data set.
Yeah, it's a really good question and something that, we certainly try to balance. I think when the SDPT was first created in 2019, no method had been developed to delineate all the types of planted trees and tree crops from satellite imagery in a globally consistent and automated way. But, there was a recognized benefit to having this sort of information at the global scale. And that's why researchers at Global Forest Watch decided to harmonize national data sources to create this global database. So there is a really good benefit to sourcing information at a more local scale. Some countries offer manually delineated boundaries, which can offer a higher level of detail than could be, efficiently produced at the global scale. Species information, like we've talked about today, can be more readily available at the national level and at the regional level as well. So it's often possible to get more detailed data at these more local levels than at the global scale. And we can benefit from that, as I think you can see, from these global use cases. There's, of course, caveats and limitations to this approach as well, but I think we're clear and upfront about these in our documentation that we've made, just as clear as possible. And I expect that, as remote sensing technology research applications, continue to improve, globally consistent high resolution maps of planted trees will become better and better over time as well. I think we kind of already saw, the release of the Global Forest Management data set by Lessive et al. A few years ago that mapped planted forest and plantation forests at 100-meter resolution. So this was, a big jump in the data that was available. So, I think down the road, the data will get better and better. But, at this time, we continue to see a need and a benefit to harmonizing these more local sources of data to provide as much detail on planted tree extent as possible.
Thanks, Jess. That's really helpful, and yeah, no, highlights the important role of why this is definitely a collaborative effort, and that's why filling out the feedback form is really helpful for us to see ways we can improve the data set. So I definitely encourage you all to fill that out and let us know. I think it relates to this next question from Justine. Can the data set be integrated into a national forest monitoring system? If so, how? Wasn't sure if maybe Jess or Aster or anybody else from the panel might want to speak to this a little bit, how it relates to some points that you previously covered, Jess.
Yeah, that's a really good question, and one that I might be better addressed, following up like offline. So I would encourage that person to reach out directly, and we can talk more about what if that's a fit for that.
Great.
But also encourage others, if they have any other comments as well. So.
Sounds good. Yeah, definitely please get in touch with us if you, especially any specific questions. I think we'll wrap up with the just maybe one or two more final questions. So this one could be interesting from Christine for the larger group. Can the updated SDPT be used to distinguish natural forest loss from planted tree expansion at the municipal level, especially in biodiversity sensitive areas like the Philippines terrestrial KBAS? So this is from someone from the Philippines, but in general, I'm curious if you can speak a bit more about distinguishing natural forest loss from planted tree expansion at that level.
Yeah, a really good question. And I think, the answer is certainly going to vary, country to country and region to region. But the planted trees data set is really helpful for discerning between tree cover loss in, planted forests versus natural forests. So I think for this reason, it's a really good chance to use that data and be able to, better identify what type of forests that loss is occurring within. For the Philippines specifically, I would have to go back and check and see just how fine of resolution data we offer for that country specifically, but encourage you to explore that data on the map on Global Forest Watch and in our dashboards. That should hopefully be able to give you some more support on if that data is effective at the municipal level for that specific use case. And so, it would be a good opportunity to explore the map in the Philippines, add the planted trees data as a layer on the map, and pan around and see how this data overlaps and if the resolution is appropriate for your use case.
Awesome. So I think we have, a bit more than 5 minutes left, but before Jess gives the concluding remarks, I see Yeah, we can maybe take these last two questions. Would it be possible to add bamboo plantations or large plantings from James? Jess would be the best person to.
Yeah, so I'll have to double check. I do believe we have included bamboo plantation. I guess I can first comment on the large plantings first. And I know that if there are large, industrial sized plantings, that's certainly something that we will include in the database. If I guess it's a large scale planting, oftentimes, that could be like an oil palm plantation. It could be, a broadleaf plantation. We certainly include large scale plantings in the database. And I just checked, we do include bamboo plantations as well. So yeah, if you have additional information on data on bamboo plantations, that is something that we will include in the database.
Great. And last question, I'll kind of combine these last two from Fabiola and Bella Chu. So it's talking about evaluating the tree cover gain data, but according to tree height and in general, I think the questions around, with Google Earth Engine, when we undertake forest cover mapping of a certain country, such as tropical Africa, it only considers forest gain up to 2012. So for example, this person, if I want to get the updated one, that includes between 2000 and 2020. So if there is Google Earth Engine, they're not for me, thanks in advance. So I guess maybe speak a bit, Jess or others, around the relationship of using tree cover gain and tree cover heights when in combination with this data set for these types of use cases, and how GE maybe could also supplement.
Yeah, so I think bringing in the tree cover gain data as well as tree cover height data can certainly, add a lot more context to the planted trees data set. Like we had talked about earlier, the forest gain data will overlap with SDPT. So yeah, highly recommend checking out the dashboard widgets that we offer to glean more information on that. But I think Global Forest Watch map is a really great resource to overlapping these, gain and height data sets with the SDPT, and yeah, being able to see at a country level, where those areas overlap and glean more information from that. In terms of Google Earth Engine, I would have to follow up directly on how the gain data, if it is available on Google Earth Engine. I do believe that data will be obviously available on Global Forest Watch at the 5-year intervals from 2000 to 2020. So I think if there are questions that you can have answered through the Global Forest Watch platform map, that would be a great resource, but can follow up with you directly on Google Earth Engine and what of those data sets are available to compare with the planted trees database.
Great. Thanks so much, Jess, for all the information. Thanks so much to all the panelists for answering all these questions. We've actually never answered all the questions during a webinar, so it's amazing. We've answered every single question. So thank you all for everyone who's come to the webinar today with these great questions. I'll now reshare my screen. You all can see that okay. And we'll hand off to Jess to conclude us with some final remarks.
Yeah, thanks so much. And yeah, thank you all for all of your questions. I think, yeah, you posed some really good questions for us during the Q&A, so really appreciate that. Yeah, talking about some future plans for the database, as we've talked about, we're expecting to see continued significant advances in large-scale planted tree mapping at the global scale, as well as at the national and regional scales. We'll continue to harmonize and integrate these sources across these scales to keep the SDPT up to date. So with that in mind, we have already started development on a version 3.0. We are aiming to incorporate more species-specific data into the SDPT in this next version. This will continue to benefit applications in forest legality, forest typology mapping, carbon accounting that we've all talked about today. So I think in this effort, continuing to collaborate with the University of Washington and JRC to improve our collection of data sources will be a great benefit If you have suggestions for data sources that we haven't yet included in the database and should consider in future updates, please feel free to fill out the Google form that is here on the slide and that we've shared a link to in the chat as well. That'll be a great way for us to collect information on new data sources to incorporate. Next slide, please. So yeah, to explore and download the SDPT data, please visit Global Forest Watch for more. If there are any questions that you think of after the webinar is concluded, please feel free to contact us. My email is listed here on the slide, and our additional speakers have also provided their contact information as well. So yeah, thank you again for your interest in the spatial database of planted trees and for tuning in today. Have a great rest of your day, afternoon, or evening. Thank you so much.